Hello friends, welcome to engineering tutorial. So this is the sixth question related to maximum power transfer involving dependent sources. So this is the circuit diagram, and here we have this dependent source, which is a voltage dependent voltage source, and this is the important parameter here, the voltage across these two terminals, the output terminals you can say. And here it has been asked, actually two things have been asked. First, to find the power absorbed by this 3.3 ohm resistor, and then to find the value of this load resistance which leads to maximum power transfer and the value of that maximum power. So again, to solve these two questions, we have to use the Thevenin equivalent circuit approach. We have to find the Thevenin equivalent circuit across these 2 points, opening or removing this 3.3 ohm resistor. Okay, so let us do that. Let us redraw the circuit. So we have (0.1 V2) this is 2 ohm, this is 5 volt, this is 7 ohm, and we have opened it, so it is VTH, which is equal to V2. So we can say this dependent source 0.1 V2, we can write it as 0.1 VTH. Okay, now an interesting thing here is that as the output terminals are opened, no closed connection, so the current flowing through these resistors will be 0 ampere. So when we apply KVL here, it will be 0.1 VTH plus 5 minus VTH is equal to 0. That implies we can write minus 0.9 VTH is equal to minus 5. Okay, 0.1 minus 1, 0.9. Okay, that implies VTH is equal to 5 by 0.9, which is equal to, let us calculate, 5.56 volt. 5.56 volt. So this is the important thing. We have got VTH, which is equal to 5.56 volt. Now we have to find RTH. So we have determined VTH. Now we have to find RTH, Thevenin resistance. So for that we have to redraw the circuit, deactivating this 5 volt independent voltage source, that is short circuiting it, and we have to connect an external excitation voltage 1 volt. So let us redraw the circuit. So it is 0.1 V2, 2 ohm, short circuited, 7 ohm, and then we will connect a 1 volt voltage. So here V2 is equal to 1 volt voltage across these two terminals. So here it will be simply 0.1 volt. V2 is equal to 1 volt. So now let us say the current flowing from this 1 volt voltage is I. We have to find this value of I. That is our objective, because when we find I, RTH will be given by 1 volt by I ampere, this much ohm. We have already done things like that, so now our objective is to find I. So putting KVL in this direction, we'll get, always assign the polarities, 1 minus 7I minus 2I minus 0.1 is equal to 0. That implies 0.9 minus 9I is equal to 0. That implies I is equal to 0.9 by 9, which is equal to 0.1 ampere. RTH is equal to 1 by I, which is 1 by 0.1, which is equal to 10 ohm. So RTH we have got is equal to 10 ohm. So you have got both VTH and RTH. Now it has been asked to find the power absorbed by this 3.3 ohm resistor. So for that we have to use the Thevenin circuit, which we have got VTH and RTH, reconnect the 3.3 ohm resistor and find the value of the power absorbed by the 3.3 ohm resistor. So 5.56 volt, 10 ohm, reconnecting the 3.3 ohm resistor. Now the current flowing is equal to, I is equal to 5.56 by 13.3 volt by 13.3 ohm total resistance. So that will be equal to 0.56 by 13.3. So that is equal to 0.418 ampere. The power absorbed by the 3.3 ohm resistor is equal to I square R. So it is 0.418 into 3.3. So it is coming around 575.7 watt. Okay, sorry, 575.7 milliwatt. So it is coming 0.5757 watts, which is equal to 575.7 milliwatt. Okay, so we have got the first part, P 3.3 ohm, power absorbed by the 3.3 ohm resistor. Next is to find RL for maximum power transfer. Now we know, as per the statement of maximum power transfer theorem, for maximum power transfer the load resistance should be equal to a Thevenin resistance, which is equal to 10 ohm, and the maximum power transferred, that is equal to PRL max VTH square by 4 RTH. Okay, so that is equal to, it is coming 5.56 square by 40, which is 110. Okay, it is coming around 0.7718 watts, which is equal to 771.8 milliwatts. Okay, so this is the PRL max. So we have got all the things that were asked: power absorbed by the 3.3 ohm resistor, RL for maximum power transfer, and the value of the maximum power transferred. So this is the sixth question related to maximum power transfer theorem to circuits involving dependent sources.